Here we go again. Casual conversational cartoon curriculum, very concise and relatively correct, as simple as possible, as soon as possible. A&P Chapter 5, fourth installment. Again, a reminder that all this material is found in the general practice questions, so you can hear and see a whole lot more easily this stuff right here. So beginning around, question number 80. Yeah, we're talking about connective tissue. Of course, your textbooks are available too. Here we go. So the purpose of the graffiti is just to sort of create a conversation, and here's a conversation piece. The word scurvy refers to a connective tissue problem, which a person lacks the proper amount of vitamin C, and the connective tissue doesn't form very easily. The way that you might remember the word scurvy is in reference to pirates, considered to be a scurvy dog or something like that. Scurvy is considered to be a slang, a contemptuous term. Well, the reason why the pirates were scurvy is because they didn't have a source of vitamin C on most of their long voyages. Therefore, they suffered from loose teeth and hair growing in patches and wounds opening up, aches and pains in their joints. And you can imagine how that would affect their speech and the way they walked, all that kind of stuff. Well, the British discovered that having a source of vitamin C in the diet of their sailors prevented most of the problems of scurvy. And one of the fruits that they chose to put on their sea voyages were limes. And so therefore the British sailors with that strange new smell on them were considered to be limeys. That was a slang term for those people. But it was a brilliant way of preventing scurvy. There are four basic types of tissues in the body. There's epithelial, connective, muscular, and nervous. And connective is by far the most abundant in the body. Connective tissue, by its name, connects things, so it's found between things. As far as the functions of connective tissue, consider this mnemonic right here, B-SPIT. Bind, support, protect, insulate, and transport. As examples, tendons and ligaments bind things together. Tendons bind muscles to bones, generally speaking, and ligaments bind bones to bones, generally speaking. Then as far as support's concerned, well, the capsules that are found around organs of the body are made of connective tissue. Areolar tissue also supports things inside the body, keeps them from rattling around, and it binds things together, such as your epidermis to your dermis, and your dermis to the structures below that. Another function is to protect, and things such as bone and cartilage are part of that story, because the bones around your brain, around your spine, your pelvic girdle, protecting the lower structures of the reproductive, digestive, and urinary system, all those represent forms of protection. Cartilage also is part of the protective nature of it all, protecting one bone from grinding into another bone at the articular cartilages between your joints. Then also adipose is a form of protection too. Silly analogy is a lineman who has a lot of subcutaneous fat actually has some extra protection against somebody bumping into him and hurting his core muscles, internal organs and such. Adipose also, of course, has a thermal insulation effect to it. Therefore, somebody who has a lot of subcutaneous fat has a kind of a winter coat under their skin. Then transport. Blood is an example of connective tissue, and of course blood transports nutrients throughout the body and heat throughout the body. It's quite obvious there. Down here, as far as what is a connective tissue made up of, well, there's materials, and then we can talk about classifications. For materials, there's cells and matrix. So here's a random cartoon of that. There are cells hanging out inside of a matrix. Now, the matrix is made up of two components. That is fibers, whether they're visible or not, and then ground substance, which is the stuff between the fibers, between the cells. Over here, the types of cells you expect to find inside connective tissue. The prefixes are fibro, chondro, osteo, and hemo, meaning fiber or thread, cartilage, bone, and blood. The root word would be blast or site. Blast referring to beginning baby building, an immature developing cell, and site referring to custodial or caretaking or curator, something that's going to take care of a tissue that's already been formed. So we can create words such as fibroblast building fibers, and then fibrocytes maintaining them. By the way, the cell that was a fibroblast becomes a fibrocyte when it's finished its job and it's maintaining things. A chondroblast builds cartilage, and when it's finished building the cartilage, it maintains it, and we change the name of that cell to a chondrocyte. Same cell, we just changed its name. Osteoblasts build bone matrix, and when they've trapped themselves and they can't build anymore, now they're just going to maintain. They're called osteocytes. And hemocytoblasts are the types of stem cells that can eventually become erythrocytes, thrombocytes, and leukocytes, the more mature form. So again, the B for blast refers to immature, and the C for cyte refers to mature. The matrix that we're talking about right here, there's a fibrous component and there's a ground substance. Even if the fibrous component isn't visible, it is there in all the connective tissues. There are three main types of fibers that are found inside connective tissue. The three biggies are collagenous fibers, reticular fibers, and elastic fibers. The collagenous fibers are made of collagen, which is the most abundant protein inside the body, and they tend to be strap-like, and they're there for strength. So very strong, they're strap-like, they're there for strength, a major component of tendons, ligaments, and capsules, and the dermis of your skin. Then there's reticular fibers, which are branched fibers. RET comes from the Greek word for net, and so these things are branched like threads in a net, ropes in a net. Anyway, these things tend to create space. That branching creates a space, and again, like we said, it comes from the word for net, and you find this in structures of your body that might be considered living filters, such as the spleen, lymph nodes, the liver, places where you want branches upon which you can place cells that interact with fluids that might be moving through them. And the third basic type of fiber is called elastic fiber, and true to its name, it's elastic like a bungee cord. And this tends to put snap into a tissue. So the dermis of your skin is strong because of the collagenous fibers. But when you pull the skin from the body outward and let go, it snaps back, and that in part is due to elastic tissue. As you get older, this stuff right here isn't as strong, and the skin may begin to droop and drag, and this stuff isn't as strong, so therefore the skin doesn't snap back the way that it used to. Put it both together, and wrinkles are a possibility. So the connective tissue is made up of cells, a matrix, and the matrix is made up of fibers and ground substance. And the ground substance is one of the main characteristics of the connective tissue, because it could be semi-liquid, like in fibrous tissues, particularly areolar, loose connective tissue. It could be a more solid, like gel material, like in cartilage, or it could be absolutely solid, as in osseous tissue, or the ground substance could be a liquid, as in vascular tissue, which of course is a fancy name for blood, and that liquid we're talking about would be the plasma.